All right, mathematicians, there was a request for figuring out how to check things, some of these homework questions from this unit with your calculator. And so I want to give you a couple examples of that. I want to show you something out of 3G, 3Q, 3L, and 3M, all slightly different variations of how to check with your calculator. So here we go. I'm not going to walk through the questions themselves because you can figure that out, or come see me if you can't, but this is just how to verify because they ask you in these. So they say, here's Z1, Z2, Z3, and multiply these, figure this out. There's Z2 star and stuff, and then give me your answer. And so I think the answer is going to be, for this first one, I think the answer is, E1E. I think it is, when you multiply all that together, I think it's going to be 90 over 169 plus 122 over 169 I. That's my solution. You're like, well, I'm not sure if that's a solution. Check in the back of the book, sure, but they say, can you check using your calculator? And here's how you would do that. I'm gonna actually take Z1, Z2, and Z3 and put them into here in the calculator. There's no button for Z2 star, so I'm just going to have to do that part in my head, but it should look like this. Here's my numerator. I'm going to open brackets. I'm going to say 2 times, new brackets, Z1 star, Z1 itself, so 1 plus I. So you'd say 1 plus second I, close parentheses. Yes, you could distribute and do some of that in your head, but you don't need to. So 4 times Z2 star, so there's Z2, so Z2 star is just 3 plus 2I, so 3 plus 2I. So there's all the numerator, and then we're going to divide by the denominator. Oh, divide by the denominator, which is Z3, which is this one, negative 2 plus 3I, so negative 2 plus 3I. Ooh. And then times Z2 star, which is 3 plus 2I. Now I'm going to have to go back. I'm putting extra brackets in here to make sure we're actually dividing by the product of the denominator. Oops. Insert parenthesis, parenthesis, parenthesis. Sorry, got a little cleanup here. If we don't do that, then it just divides by this one and then later multiplies the whole thing by that one, implying that that one's in the numerator. So you just have to be careful with it. That's gross. Math, frac. Ba-boom. Right, 90, 169, 122, 169. That's exactly as I predicted. I'm good to go. Again, that move was, it's all decimals, go to math. Everything good in life is in the math button. In frac for fraction, like please turn me into a fraction. Bam. Neat. Okay, so there's that one. Here's second one. Here's 3Q. So this says I have a system of equations. I tried to pick the ugly ones. So here's a system of equations, and I think that we want to try to find x's and y's. So I did it. Hooray for me. And I think that the x's look like this. The x's turn into 1737 plus 2215I all over 901. Obviously. And the y values are negative 109 plus 175I. You have to excuse me, writing with a mouse. It's kind of slow. And 53. So I think that those are my two solutions. What we can do is actually put them in for that point and that, put them in for this and this, and we should get this out. And later we could put them in for this and this and get this out. I'm just going to do it for the numerator just to show you, or just for, sorry, the first equation. So I think this should look like this 1 plus 4i, so 1 plus 4i times, no, yeah, times x. So I'm going to put all of that in. So again, I'm going to put a little parenthesis for the numerator, 1737 plus 2215i. There's my numerator. Divide by the 90191. Close parentheses. So now that's x. No, that's 1 plus 4i. And this is all x. And then plus, I'm just going to open some parentheses, 3i, and then new parentheses for y. Now notice that this is negative, all of this stuff. So maybe I'll distribute the negative into here, or just parentheses with the negative in front of it. So we'll go negative. So I'm going to open a new parentheses for the numerator, and then say negative, all of this stuff, negative 109 plus 175i, close parentheses, that's my numerator, and then divide by 53. That's my denominator. Now I've got I, right? So there's 3i times y. Let me say go, baby, go. Hey, look, 2 plus 4i. 2 plus 4i. Ah. Okay, so there's that one. We checked it with our calculator. And yeah, let's do that one. 3L looks like this. We have this polynomial, and they say factor it. I know here's a factor and it has a multiplicity of 2, find the rest of the stuff. I'm not going to beleaguer the point with how we solve this. You can figure that out or come find me and I can help you. But I think the solution is that f of x, when we factor it, f of x is this, and it could be written as x plus 2 squared. See, has a multiplicity of 2, and the leftover stuff is 3x minus 5. I think that this f of x and this f of x are exactly the same. So, graph them. Let's take a look. So 3x cubed, I'm graphing the top one, plus 7x squared minus 8x minus 20. We graph that. Looks like that. You may have to monkey with your window to get it look nice, but you'll notice if they're not the same. So I think that this is the same as this equation. They should look the same on the graph if they're the same equation. So let's try x plus 2 squared, and then times 3x minus 5. Let's see. Zoop! Ah, they're the same. If they were not the same, if I was wrong, they would look very different, right? And so those are not the same functions. But if they are the same functions, then they should sit nicely on top of each other because they're the same graph. Cool? Okay, so there's checking that one. And this last one, I monkeyed with this one for a while. I just couldn't find a good way to check it with the calculator that was intuitive. So I would not worry about this one. They don't actually ask you to check these on the assessments, but it does tell you some things about what's happening. But I don't know. Just to walk you through why I don't think this works that well, if you're interested. If we graphed this, minus 7, okay, and then minus 10, so this should be minus 17. Yeah, I'm looking at 2a. That looks like that, and I noticed that it only has one intercept. Right? I think even if we make this like negative 50 and 50, still really only has one intercept. So we could find that intercept with second calc or second trace and find a 0, but yeah, it just, I don't think it nicely can simplify. So we can get an intersection, and we could kind of work with that, but it just doesn't seem like there's any nice quick way to check this that I see off the top of my head. This equation turns into, with this equals 0, this turns into x minus 1.74 blah 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 blah, and then times two different little invisible complex numbers, a plus bi and a minus bi. And to get your calculator to give you these two, requires a tremendous amount of work. It's easier to just solve them by hand. So this one, I don't know. Check your answer using the calculator. Skip. Pass. Cool. Anyway, I think the other three are fine. You should be able to do those, but this one was clunky. I don't buy it. So I hope that helps, and we'll see you later.